So, quotient rule. So if something divides something, the answer is a quotient. That's where the term comes from. Okay, simple as that. It's not really life-changing knowing that, but it's relevant. So we've got sine x divided by 2x squared. Haven't we, Ishi?
Yeah.
So we've got that divided by that. So the answer is going to be a quotient, so hence the name. And same as before, we can't use a sum rule. It's not as simple as a sum rule. We've got to use a special way of doing it, and we're going to use this is the rule that's been devised. Again, from long drawn out first principles that you don't want to get into. Right, let's have a look. So that's y equals, so dy dx equals, so this is, we'll define as u, this will define as v, and it does matter, let me make that more like a v rather than an r. It does matter which way around they are. You can label them the other way, but then you'd have to swap your formula around, so it's pointless. So you've got to be a bit more careful. So what we've got v as it comes, so we've got this term here as it comes, 2x squared, and then it's times the derivative of the u at the top. So the derivative of sine x is cos x, yeah. Almost got an answer. And then it's a minus sign. So you're just following it, the rule, left to right. Simple as that. And it is that simple. Now we've got u as it comes, so sine x times the derivative of this one. So yeah, 4x. Simple as that. And that's it, all divided by v squared. So that's going to be 2x squared squared. So I can simplify that, can't I?
Yeah, 2x to the bottom.
Yeah, let's do a bit of... that's okay as it is. Bring this to the front. Whoops, forgetting to bring it to the front. All divided by... So what would this become if I squared it out? Not if I squared it out, but if I distribute it out. Say again?
4x.
To the 4, yeah. Yeah, perfect. Okay? So there's not much more I can do with that. Sometimes you can do a bit more simplifying and a bit sort of rearranging, but not on this one. Okay? Move on. Number 2. Second one. Let's have a look at...
So, do you just leave that as it is, like that? So that's
this way? Yeah, that's fine. So from that I can find the gradients at any value of x. So I'd have to put, say I wanted to know it at 2, I'd have to put 2 into every place as an x and do the maths. Get my calculator out and just do it. Okay? So, second one. Let's go with... that. Let's say... something like that. Okay?
Why is that in brackets?
Because it has to. What it's saying is that is divided by that, the whole of that. So if you were doing this as a function, which I should have y equals there. If we're doing this as a function, you'd have to solve that before you divided the top by 8.
So when you square that, you're squaring the full thing. Or you...
When I come to square it later, yeah, it'd actually end up being a quadratic. Okay, when we get to that stage. Okay, so dy dx. So again, this is me u on the top, v on the bottom. I'm not going to write it on anymore because we know it now. 2 cosine 2x. It's well, we start with v as it comes. So that's 2x plus 12. Nothing done to it. Times the derivative of u. So the derivative of 2 cosine 2x is 4 sine
Is it minus?
2x. It is indeed minus, that's why I left the gap. and put it in brackets because it's a multiplier. We don't want to end up subtracting it later on for clarity. Is that right, guys? There, you listening?
Yes, right, Florence.
Okay, and then the next thing is a minus sign. It is to subtract, not like that one that's in a multiplier. And then we've got u as it comes, which is the top. 2x times the derivative of the bottom. Right, here we go. 2x plus 12. What's the derivative of that? So, give you a heads up. We're going back to the sum rule now, where you treat each term individually, because it's in brackets.
So 2 is 0. 2 plus
Just
1 is 0.
Just 2.
2 plus 1?
0. If you don't have x, 0.
Yeah. Any constant, anything without an x, is 0. Remember. Funny enough, it's the easiest one of all,
Is it
but
not
everybody
1?
forgets.
Because that's basically.
No, it's 0 because
There's no x.
it's that, isn't it? So you've got 12 times by 0 is going to make that to 0, and then everything's going to be 0 after that point. Okay? If it's 12, the 2x is to a 1, so that just becomes 2, doesn't it? Because the 1 multiplies to 2, and then the x becomes x to the 0 when you take 1 away, and anything to the power 0 is 1, so you've got 2 times 1 equals 2. Okay? So it's just going to be 2. All that it gets easier. Okay? So that's just 2 times 2. If you're confused, put a dot in there. Okay? So all over, that's it. 2x plus 12, all squared. And you could multiply out that if you wanted. But I'm not going to bother, because that's not what we're here for today, to do find quadratic equations. Right, so a bit of tidying up though would be called for.
A machine. Yes, I wanna be a machine. If you're a machine, it can't be so bad, 'cause no one built you to be sad. And in my cold, still heart, I'd know I was built to be alone. A steel body can't go to hell when you got no soul left to sell.